All right, the next thing I want to talk about is compound and continuous compound interest. So basically it's compound interest and continuous compound interest. Okay, now compound interest is when interest is occurred so many times throughout the year. Okay, so for example, like if you deposit $1,000 into a bank account and it's compounded quarterly, that means that at the end of the year, interest has been paid on your account at the end of each 3-month period because it's quarterly. With this, you have two equations. Let me clear this screen. Okay, I'm going to break up. Okay, if it's compounded continuously, it's going to be A equals PER to the T. Now that's raised to the RT. Okay, so it's PE raised to the RT power. And then anything else, if it's compounded monthly, daily, quarterly, semi-annually, any other type of compounding, it's going to be A equals P, open parentheses, 1 plus R over N raised to the NT. Okay? Now, both of these have very similar variables because we've already talked about them. A means future value for both formulas. P means present value or principal for both formulas. R means rate, usually in percentage, but we know we have to change it into a decimal. T means time. Okay, usually in years unless otherwise stated. E is only on the right side. It's only in this formula. Now, E is a number. It's a constant. It's like 2.174 and some change. It's like pi. Pi is 3.14, and it goes on forever. E is the same thing. It's a 2.174 and some change. So that's it. So everything over here is accounted for. We know what A stands for. We know what P stands for. We know E is a number. We know rate and time. On the right side, we know A, P, we know R, we know T. We just don't know N. N is the number of times your interest is compounded. Okay? So if they tell you, hey, it's compounded daily, either it's 365 or 360, depending on if it's a business year, and they'll always let you know that in the problem. Okay? That's if it's compounded daily. If it's compounded monthly, you know that it's 12, because there's 12 months in a year. It's how many times it's compounded in a year. If it's compounded quarterly, you know that N is 4, because it's going to happen every 3 months. If it's annually, you know N is 1. If it's weekly, you know N is 52. 52 weeks. Okay, so those are just like the most commonly ones to use. I also see semi-annually a lot. Semi-annually would just be 2, that it's every 6 months. Now, sometimes the problem is going to be nice to you, and it's going to give this part to you for free, and it labels this as I, and it'll tell you what I is. Okay, same thing over here. Sometimes it won't give you the time because it's already going to give you N, the number of times it's been compounded. So these are the very general formulas, so just make sure you look at what's given and go on from there. All right, so let's try a problem. I want you to use the compound interest formula to find the future value A for the following values. Let's say that P is $1,500. That's $1,500. I is 0.07, and N is 30, okay? It will not be compounded continuously because they gave you your N, We're going to use the formula A equals P, open up parentheses, 1 plus, instead of R over N, they're already giving us I, and they're giving us how many times it's been compounded. So then it's just a simple plug and chug. 1500, 1 plus 0.07 raised to the 30 power. I get 11,418.38. Remember, we're dealing with money, and most of the time you're going to round to the nearest cent, but just be careful and make sure you read the blue fine print so you know exactly what you need to round to. Alright, so let's say I said given the annual interest rate and the compounding period, I wanted you to find I. Okay? The interest rate per compounding period, knowing that it was 6%, compounded monthly. Well, if you go back to the very original problem I gave you, it's compounded monthly, and remember, R over N is I. So your rate is 0.06, because remember you have to change it into a decimal. Your N is 12, because you're compounding monthly. This gives you 0.005. But we're looking for a percentage, so we have to change this into a percent, so we're going to move it to the right 2 times. So your answer is going to be 0.5% equals I. Okay, I just want to kind of see, I wanted you to see how it ties in with the formula that I gave you and the formula that you see in your book. Now, throughout your all of your homework, I can give you a formula and I can give you all of your pieces except one, and you're going to have to use basic algebra to find out what you're missing. So for example, let's say I said, given the rate per compounding period, I wanted you to find R, the annual rate. So I told you it's 1% per month. So now it's like I'm giving you I. I'm giving you I and asking you, hey, what's R? Now you know that I equals R over N. So fill in what you know and find what you don't. We know that I is 1%, so we know that's 0.01. We don't know what R is, but we know that N, they're doing it monthly, so N is still 12. So now they're dividing by 12, so I'm going to multiply both sides by 12. Let me try this in a different color. I'm going to multiply both sides by 12. These 12s cancel. I get R equals 0.12, but then of course we're going to present our answer as a percentage, so I need to move this over 2 times. So R equals 12%. Okay, let me try one more problem. A newborn child receives a gift of $6,000 toward a college education from their grandparents. How much will the $6,000 be worth if it's invested after 19 years? Okay, if invested at 7.4%, compounded quarterly. Okay, and so I'm going to use the formula that I showed you at the very beginning of the lecture. I'm going to have A equals 6, A is 6,000 equals 6,000. 1 plus R, which has to be a decimal, 0.074, over N, and N is compounded quarterly, so N is 4, raised to the NT, okay? Because remember, in your book, they replaced this with I. And then here, that exponent has to be the number of times compounded. Okay, so that's NT. N is 4 times how many years? 19. Okay. Now, you can break this down piece by piece if you don't have a calculator, like a TI calculator. You know that 19 times 4 is 76. 1 plus 0.074 divided by 4. So now I have 6,000. I don't know why I want to put a 1 in front of that. 6,000 1.10185 raised to the 76th power. And I get $24,165, it's a comma, not a decimal, $65.17. That's how much the money would be worth in 19 years. All right, so that's it for compounded, like quarterly, annually, semi-annually, and then I'll make another video with compounded continuously and show you the difference. All right, have a nice day.